So we're taking a look at this word problem here, number 12, and as I'm reading through this, I'm going to make sure I'm circling any totals that I might come across. So it says the sum of the two numbers is 25. So that total is always going to be next to the word is. And the first number is one more than twice the second number. So whatever the first number is. So that's when I got to define my variables. So I've got x and y, and I'm going to call x my first number and y my second number. So the sum of those two numbers is going to be 25, so that's just x plus y equals 25. I'm always setting my equations equal to those totals I found. So my second one I know is going to be equal to the first number, which we defined as x. And then it said it is one more than twice the second number. So as I'm reading this, I can literally write one more than, so add, twice would be 2, times the second number would be y. So 1 plus 2y. Now I'm just going to use elimination here to solve that. But before I do this, I'm going to copy my equations over here. Now, I'm going to, I think I did say elimination. I just realized that it is solved for x already in this equation. So anywhere I see an x up here, I'm going to put in a 1 plus 2y. So I'm going to use substitution for this problem. So 1 plus 2y plus y equals 25. 1 plus 3y equals 25, minus 1, 3y is equal to 24. And then I'm going to divide by 3 to get y equals 8. Now, from here, I can put it into either equation, but since I already have this second equation here solved for x, I'm going to pop the y into that equation. So then it will give me x right away. So 1 plus 2 times 8 equals x. 1 plus 16 equals x. 17 equals x. So my solution is 17, 8, and I'm always remembering to check my answers on these. So I'm doing the same thing on this problem as I read through it. I'm looking for that word is or other verb tenses of that, and I'm going to circle those numbers next to it, those totals next to it. So this says Kevin had 13 coins, so I'll circle 13 there, in his pocket. All of his coins are either dimes or quarters. When he emptied his pocket, Kevin found that he had $2.05. See that total there again. How many dimes and quarters does he have? Back to when I'm defining my variables. I need to make sure I can answer that question when I do so. So how many dimes and quarters does he have? Well, I'm going to say D equals the number of dimes, and Q equals the number of quarters. Now I'm going to set up my equations. I'm going to set one equal to 13 and another equal to $2.05. If he just had 13 coins, I just need to take the number of dimes plus the number of quarters equals 13. So that's going to look like D plus Q equals 13. Then the second equation is where I need to take into account of how much each coin is worth. So I'll be multiplying 0.10D plus 0.25Q, because a dime is worth 10 cents and a quarter is worth 25 cents, but we always put them in decimal form when we are writing out these equations. And now we can go to solve it. I'm going to use elimination for this problem. And I'm going to do that by eliminating the D's. I'm doing that because when I multiply that first equation by a negative 0.10, I know it's easy to just move the decimal place for the 13. So it becomes negative 0.10D plus negative 0.10q is equal to a negative 1.3. I just move the decimal place over 1 because it's a tenth. If not, just use your calculator. Then I will add those down, and the d's will cancel, and it will become 0.15q, because that's 0.25 plus a negative 0.10, and that is equal to 0.75. Now I'll divide by 0.15, to get q is equal to 5. Then I'll go back to my first equation, because that's a lot easier math to multiply out than multiplying it by 0.25. So I will have d plus 5, I'll substitute in that q there, is equal to 13. I'll minus 5 to get d equals 8. Again, you can check these. You need to check on every problem. There's no excuse to get these systems wrong. So our solution is 8 dimes and 5 quarters. So this problem reads, Old MacDonald had a farm. On his farm he has some ducks, and he also had some cows. If you count all of the legs of all of the animals on the farm, you will determine that there are 112 legs. There are a total of 44 animals. So there's our two totals on the farm. How many cows and ducks does Old MacDonald have? So when I define those variables, I need to be able to answer that question. So C equals number of cows, and D equals number of ducks. Then I'll set my equations equal to those totals we have, and I'll look at the legs first. So I need to take the number of those cows and multiply it times however many legs they have. So cows have 4 legs, so that will be 4C plus 2D, ducks have 2 legs, to give us the total number of legs, because it's 4 legs per cow and 2 legs per duck. And then the last equation, it just says there's a total of them, of that many animals, so you take the number of cows plus the number of ducks is equal to 44. I'm going to copy that problem down here. And I'm going to use elimination, and I'm going to multiply that second equation by a negative 2, because I want to cancel out the d's. So it becomes, I'm going to copy the first one again, and then the second one. Now it becomes negative 2c minus 2d equals negative 88. My d's cancel, and that becomes 2c, because I'm adding here, so a positive 4 plus a negative 2 is equal to 24. I'll divide by 2 to get c equals 12. Then I will plug that into the second equation, so I don't have to do any extra multiplication, and it'll be 12 plus d equals 44. I'll minus 12 to get d equals 32. Again, you check these both, and you'll find that our solutions work, and it will be, there were, on the farm, he had 12 cows and 32 ducks.